Alright, so 6, 9 is just more of the same. We're continuing to multiply polynomials. We're going to kick back in with where we were yesterday. Yesterday I gave you 2 ways to do the squares. What was one way to do the squares?
Copy it.
Just copy it. Put twins beside each other. And that's perfectly valid. I'm not going to criticize that at all. But today's book lesson, they're emphasizing a shortcut that I gave you yesterday that involved just kind of like repeating a pattern of how these always go. Does anybody remember the pattern for how this would start to go? I'm going to go first thing times itself, which would make x squared. So if we go first times itself, that gets us going. Anybody remember sign here?
Positive.
A plus always, or because we copied?
Copy.
Because we copied. The next sign?
Plus.
Plus always, or because we copied?
Always.
Always. Do you remember how it ended? 9. How'd the 9 come?
3 times 3.
Yeah, the second one times itself. And then do you remember what went in the middle?
3x.
3x was involved. We would take the first one times the second one. That is 3x in our mind, but on my board
6x.
it is 6xy.
Because you would double it.
Why were we doubling it? That is true.
Because it's to the second power.
Maybe. If we put this side by side, imagine in my hands another x plus 3. We get 3x, and we get put it on the board instead of imagination. This would get us 3x. This would get us 3x. There's always going to be 2 of those because we kind of like have the twins. If you have to write it out to see it and do it, go for it. But they're trying to coach you toward just doing this off of the pattern. Question about the pattern? Let's try it again. We'll go down the column doing the pattern. If you get to the quiz and you forget the pattern, don't do it. Just write the twins and like FOIL it out. Well, this would start with
X squared.
x squared,
Negative.
negative, sign here,
Positive.
positive,
16.
16, and then the middle's where sometimes things go funny.
X.
8x is right. I'm going to make other voices say things, so before we go on to that, anybody want me to try to explain how that voice came up with that one? So let's get a different voice. Any other voice than that one?
X squared.
True. That was 2x times 2x, if people are not sure why. Collaborative voices, some other voice, or that same voice.
10x.
There is sort of in there. It is a 20x. So 2 times the 5, that's 10x. But we always double, so that's 20x. Somebody say something during the call.
A 10x. 25.
25. 5 times 5 does the 25. Sign here,
Positive.
always plus. Sign here,
Plus because we copied.
plus because we copied. Question about that. How about second row, some voices?
Oh, 6x.
No.
9x
9 is good. 3 times 3 is 9. X times x
squared.
is x squared. I like that.
Minus.
Minus because we copy. Later on,
36.
36 from 6 times 6.
Negative. Wait, pause.
Sign on that is plus always. And then the middle's where we get jammed up sometimes, so any voice I'll take it.
32x.
That's warm, it is in the 30s of
36.
axis. It is 36. 3 times 6 is 18, double 18 is 36. Something about those four. We'll go one more time, anybody. So again, the pattern, take the first thing times itself. So first thing times itself, this time there's an exponent involved.
9
There's a 9,
x to the third. Or
not third anymore. If we do
To the
thirds
sixth?
times thirds, it's to the sixth, because when we multiply, we add. So thirds times thirds are sixes.
Minus.
Minus to copy later on,
Positive.
as always. Do the n next, I think that's easier. 6 becomes
36.
36. Y's grow
8
to 8. Here it's the same x3, and so it's the same
Y4.
y4. It's just a question of how to manage that number set.
36.
It's 36 again. If you're with that pattern, do that. It is quicker. If you're not with the pattern, just go ahead and write this next to itself and do the foiling lesson from like 2 days ago. Yesterday the video got cut off, so that's like how we were doing the squares yesterday. We did the pattern one way. We also just wrote this beside its identical twin, x minus 4 next to x minus 4, and just foiled it out the normal way. Those are both ways to do that. Questions left of the line? Right of the line gets easier. So what we have here is two factors that are almost the same. The only thing different is their
sign.
sign. So I'm going to do this out the long way first, and then we're going to shortcut the rest of these. So if we multiply these, 2 items times 2 items, I'm going to get
2
4.
4 at first. So what's one thing I get?
x to the second
X to the second from first times first.
minus 4x
A minus 4x from the outside item.
plus
A
4x.
plus 4x from the inside item.
No, it's an 8 though,
Not an 8.
not an
Negative 16.
16 and negative. When these are different, we get negative. 4 times 4 is 16. We could have done that several days ago. When you go to combine, an interesting thing happens. And when we went over the homework, one of the problems I was saying, an interesting thing happens, but we kind of drew a blank for a minute. What interesting thing happens here when you try to combine?
Cancel.
Yeah, who's going?
4x and 4x.
The 4x and the 4x. So all we're left with is x squared minus 16, because those just wipe each other out. This one moment in time, if the factors are almost twins, but they have different signs, you don't have to really fully FOIL, because the outside and the inside are always just gonna cancel away. So for a one problem set, you can just fool, if you like that acronym better. Just get firsts and get lasts. Just take the first one times itself, throw it down. Do the last one times itself and throw it down. And if the signs are different and you multiply, that's always going to be a minus. So x times itself,
x squared.
x squared, 6 times itself
Negative 36.
is a 36, and we're always going to go with minus. It's a pretty good trick. Question about that so far. This has a name. This problem type will be back. I'll forewarn you. Everything that this chapter we're doing forward, you've been around long enough to know,
Already done.
it's gonna
Go back.
go back the other way. So when we go back the other way in a future chapter, these problems are called difference of squares problems. Difference is a word always means to subtract, so we're always going to be getting subtracting today. The whole way down the line, everybody is subtracting. And then squares are numbers like 6 times 6, 4 times 4. even powered things, and like numbers that you can do square roots of. Like, it's just how that is. But if you file away the title difference of squares, that'll be helpful to your future. But anyway, take this times itself, and we start with
4x squared.
4x squared, and then the 3's turn into
9.
9. And that's all that these are doing. Something about that? So 5 makes 25.
X squared.
X squared. 6's make
36.
36. And if I go with some higher power stuff, 5's still make 25's, and 6's still make 36's. But the x squared's got to grow
A 4.
to a 4, and the y cubed grows to
A 6.
a 6. Because when we multiply, we do what to the powers?
We add them.
We add them together. We've been doing that all chapter. So homework tonight's going to be just these two special cases. These are called perfect squares. These are called differences of squares. That's the two kinds of foiling that we're doing today. Let me grab my notes paper and see what we have. Homework wise, we're up a page or two. Today we're to 258. 258, we're going to work 1 through 8. 1 through 8 are all perfect squares. We skip a few. We'll go 13 to 24 is a mix of perfect squares and these differences of squares. They kind of have them blended and mixed and matched. And then try 32. 32 is just like, it has a little bit more, a few more variables than it does numbers compared to the other ones that we did, but it's the same idea. So 258, 1 to 8, 13 to 24, 32, 6, 9 is covered. The little quiz that we've been doing, it's been growing every day. Yesterday's was 12. Today's we'll have, that we'll do in a minute. Today's will have a square on it that you could do either by writing the quiz side by side or doing this pattern that I'll have to erase before I give you the quiz. It'll have one problem with 2 terms times 3 terms when we do it. And then when we get around to next time I see you, which present calendar has Monday off of school for President's Day and seeing you Tuesday. The Tuesday quiz for you guys, the next quiz for some other year watching the video, it'll have one of these difference of squares kind of set up. Where could you multiply out all 4 if you forgot the trick?
Yeah.
Yeah. Just once you did it, 2 of the terms are always gonna
Gonna cancel
you
out.
just cancel out, and then you might remember, oh man, I didn't have to do all that. There was a trick to these. But if you forget the trick and just do your normal foiling, it'd be fine. It's not going to get anything wrong. Question at all about the squares or the difference of squares or what we're doing for next time? Okay, so we're going to stop there.